Hi, welcome back to AP Physics C, Mechanics Unit 2 on Newton's laws of motion. So we've talked about the first three laws, first, third, and then second. First being equilibrium, third being equal but opposite, the action-reaction pairs, and then the second dealing with the mathematical formula F equals ma. Now let's talk about what happens when we expand the F equals ma, and actually the first law, into a full-fledged problem-solving strategy. All right. So the way that I like to talk about problem-solving strategy is to three words, right? Draw, sum, solve, right? So there. Draw, sum, solve. So the first step, draw. You're going to be a situation, a car traveling down the road, coming to a stop, something rolling down an incline, tension problems. But what you want to do is, the first thing you do is draw the free body diagram, which is going to show all the forces acting on the objects, okay? Now, you can use a dot, as they do here in this picture, or sometimes you can use just simply a square. And that square and that dot represents essentially, the center of mass where all of the forces are going to originate from. Once you have the free body diagram drawn, then you're going to move to the sum step. So you're going to create what are called vector sums for each direction. Now, it could be horizontal only, it could be vertical only, or it could be both. And then you're going to set them either equal to 0 or m times a. It'll be set equal to 0 if it's like an equilibrium problem, so that's more first law, or m times a if it's more of a second law problem. In fact, the 0 or m times a are the same thing. It's just that in a first law problem, the acceleration, of course, is 0. And then finally, you're going to solve for what you're looking for, right? That's the final step. So you're going to take those vector sums that you just written. So typically, I like to have students do an XY chart, okay? And we would simply say the sum of the forces in the X is m times a. Sum of the forces in the Y is m times a. Now, if it's equal to 0, instead of writing m times a, you can simply write 0, okay? And then you can go down and write the vector sum. So if we're looking at the diagram here to the left, this free body diagram, then I would have like F minus A21 equals MA. And then if it's a book on, something accelerating on a table, you would have normal force minus weight equals MA. And then you just solve for what you're looking for. In fact, if it's something on a table, that would be 0. This just tells you that it balances out. And so let's say I was looking for the acceleration or the size of that force. Then I just go into simple algebra, right? And it's a system of equations, two variables, two unknowns potentially, and then just solving for what we're looking for: acceleration, another force, friction, some of these other common forces that we're going to talk about in the next video.